Bottled water looks incredibly simple when you pull it off a store shelf. Crystal clear, flavorless, refreshing, sealed behind a thin plastic cap. But behind every bottle is an enormous industrial system, working with microscopic precision to purify, filter, disinfect, bottle cap, seal, and ship water in a matter of seconds. Modern bottling plants run like sterile stainless steel factories where pumps, filters, UV lights, ozone injectors, blow molding machines, and high-speed filling carousels combine into one of the fastest and most hygienic beverage production operations in the world. And today on The How Factory, we're going inside that system to see how raw water from springs, aquifers, or municipal sources is transformed into the consistent, ultra-clean bottled water that ends up in supermarkets worldwide. The journey begins with the source, and the source varies. Some bottled water companies rely on deep underground aquifers where water has slowly filtered through rock layers for decades or even centuries. Others draw from natural springs, mountain runoff, or municipal water supplies. Regardless of origin, no water enters the bottling line before passing through intensive testing. Sampling stations measure pH, conductivity, turbidity, total dissolved solids, and microbial counts. Laboratories run chemical and microbiological analyses to check for trace minerals, metals, organic compounds, and any sign of contamination. Even spring water, which is often naturally clean, must be tested to meet strict regulatory standards. When the water passes initial screening, it enters the purification stage. For municipal-sourced water, pre-treatment begins with large multimedia filters filled with layers of sand, activated carbon, anthracite, and gravel. These filters remove sediment, color, chlorine, organic compounds, and odors. Activated carbon plays a crucial role in eliminating volatile organic compounds and improving taste. Next, water flows into microfiltration units, systems filled with membranes containing microscopic pores that trap remaining solids, bacteria, and suspended particles. Depending on the facility, the water may then undergo ultrafiltration or nanofiltration, each step filtering out smaller and smaller particles, down to fractions of a micron. For brands that produce purified water rather than spring water, the next stage is reverse osmosis, a high-pressure process that pushes water through semi-permeable membranes that remove dissolved minerals and most contaminants. Reverse osmosis systems operate at pressures capable of stripping water down to near pure H2O, and the process produces a waste stream that is treated before disposal. But membrane filtration isn't the final step. After RO, water typically enters a UV disinfection chamber, a stainless steel tube fitted with high-intensity ultraviolet lamps. UV light destroys bacteria and viruses by breaking their DNA, providing a chemical-free sterilization method. Immediately after UV treatment, water passes through ozone injection. Ozone, a powerful oxidizer, disinfects any remaining microorganisms and sterilizes holding tanks and pipelines. Ozone naturally breaks down into oxygen over time, leaving no chemical residue in the bottled water. The entire purification system operates in closed-loop piping, made from sanitary stainless steel to prevent contamination. Automated valves open and close based on flow rates, tank levels, and sensor readings. Operators monitor everything from a central control room with touchscreens linked to dozens of sensors measuring pressure, flow, temperature, ozone concentration, and filter status. Meanwhile, in another part of the plant, the bottles themselves are being made. Most modern bottling facilities create their own PET plastic bottles on-site using blow molding machines. These systems begin with tiny test tube-shaped preforms that arrive from plastic manufacturers. Preforms are fed into a heating tunnel where infrared lamps soften the plastic to a precise temperature. Then, high-pressure air, sometimes over 30 bar, blasts inside the preform as it is stretched inside a mold, rapidly expanding it into the shape of a full-size bottle. Within seconds, the bottle is formed, cooled, ejected, and placed onto a conveyor leading toward the filling hall. Making bottles on-site eliminates transportation costs and reduces contamination risk, since the bottles go straight from molding to filling without exposure to outside air. Workers rarely touch the bottles. Robotic arms and air conveyors do all the handling. Inside the filling hall, a controlled, sanitized environment, often rated as a clean room, the air is filtered, pressure controlled, and constantly renewed to keep particles out. Before bottles enter the filler, they pass through rinsing stations where sterile air jets or filtered water blast out any dust or plastic particles from blow molding. The bottles then move toward the filling carousel, a giant rotating machine with dozens of filling nozzles arranged in a circle. As bottles slide into position, sensors confirm alignment. The filler drops its nozzles into the bottle mouths and dispenses purified water with astonishing accuracy. High-speed bottling lines can fill hundreds of bottles per minute, with each bottle taking only a fraction of a second to fill. Flow meters and pressure controls regulate the volume. If a bottle is missing or misaligned, the system instantly pauses that station and ejects the faulty bottle. In some premium brands, nitrogen dosing occurs just after filling. A droplet of liquid nitrogen is injected into the headspace of the bottle. As the nitrogen evaporates, it expands, increasing internal pressure and strengthening the bottle structure for shipping. After filling, the bottles move to the capping station. Caps arrive in sanitized hoppers, pass through UV tunnels, and are oriented by spinning feeders that shoot them onto capping spindles. Each cap is screwed on with precise torque so it seals securely without stripping threads. Tamper-evident bands snap into place as the cap tightens, ensuring customers can see whether a bottle has ever been opened. Sensors confirm cap presence, torques, and seal integrity. Any bottle lacking a perfect seal is rejected automatically. From capping, bottles travel to labeling. Modern bottling lines use high-speed wraparound labelers that apply plastic shrink sleeves or adhesive labels at full conveyor speed. Cameras verify correct label position, barcodes, brand graphics, and date codes. After labeling, bottles travel through neckband shrink tunnels, heated chambers that tighten plastic shrink bands around the cap if the brand uses tamper rings. Then the bottles proceed to case packing. Automated packers count bottles and arrange them into groups of 6, 12, 18, or 24, depending on package type. A robotic arm or mechanical loader places bottles into cardboard cartons or shrink-wrap trays. Case erectors fold and glue cartons automatically while shrink tunnels heat-wrap plastic film around trays to secure the bottles. Cases then move to palletizing robots. Large robotic arms equipped with suction grippers or mechanical clamps that stack cases into tall, perfectly aligned pallets. Each pallet is wrapped with stretch film to prevent shifting during transport. Pallets are scanned, labeled, and recorded in the plant's inventory system. Temperature and humidity control are important, even after bottling. Many plants keep filled water in climate-controlled environments, so bottles remain stable and do not deform under heat. Warehouses use automated retrieval systems, forklifts, and conveyor lines to stage pallets for shipping. Throughout this entire process, quality control never stops. Lab technicians collect water samples from various points in the purification and bottling line. Incoming raw water, RO output, UV output, ozonated water, pre-fill water, and finished product. They test for microbiological contaminants, mineral content, turbidity, conductivity, flavor, and chemical composition. High-performance liquid chromatography and ion analyzers detect trace impurities at parts per billion levels. Technicians also test empty and filled bottles for structural integrity. Some facilities use pressure testing, squeeze tests, drop tests, and thermal testing to ensure bottles hold up during shipping. Food safety protocols are intense. Production rooms are sanitized regularly. Equipment undergoes CIP, clean in place, cycles using hot water, alkaline cleaners, acid rinses, and sanitizers. CIP systems connect directly to tanks and pipes, cleaning the entire network without disassembly. Workers in the filling hall wear sterile clothing, hairnets, gloves, and face coverings. Air showers blow lint off clothing before entry. Metal detectors and X-ray systems inspect packages to ensure no debris, broken plastic, or foreign objects make it to shelves. Meanwhile, water destined for mineral water brands requires careful mineral balancing. After purification, technicians may add back small amounts of calcium, magnesium, potassium, or electrolytes to match the brand's flavor profile. These minerals are dosed with high-precision pumps and mixed uniformly in large stainless tanks. The water then passes through a final polish filter before bottling. Once pallets are ready for transport, logistics teams coordinate shipments to distributors, warehouses, and retail centers around the world. Refrigerated containers aren't necessary for bottled water, but trucks must keep bottles away from extreme heat. RFID tags and barcodes track every pallet, ensuring full traceability from source to shelf. When the bottles arrive at supermarkets, they are unpacked, stocked, and sold to consumers who never see the enormous infrastructure behind that simple, clear product. What makes bottled water manufacturing remarkable is how much engineering goes into something that appears simple. Multi-stage filtration, high-pressure membranes, UV sterilization, ozone systems, clean room filling, robotic packaging, precision blow molding, and continuous microbiological testing, all combine to produce water as pure and consistent as a pharmaceutical product. Every bottle is the result of physics, chemistry, mechanical engineering, and quality control systems operating at blistering speeds. And that is exactly how bottled water is extracted, purified, microfiltered, UV treated, ozonated, bottled, capped, labeled, palletized, and shipped worldwide. An intricate blend of fluid dynamics, high-speed automation, food safety science, and industrial-scale engineering, hidden behind the most ordinary product on the shelf. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machines, factories, and systems behind everyday products.